Howdy. Today we're going to look at something called prime factorization, or finding the product of prime factors. Prime factorization is the representation of a composite number as the product of its prime factors. So to explain that, if I take a composite number, a number with more than two factors, I can break it down into all of its prime factors, or basically prime factors all multiplied together will give me that composite number. So let me show you two ways you can do this. The first way is called a factor tree, and what you do is you take a composite number, we'll take 60 in this case, and we'll start breaking it down. I know that 60 equals 6 times 10. I can also further break down 6 into 2 times 3, and I can break 10 down into 2 times 5. I'm not going to bother with using the number 1 and itself, because we all know that once we get to prime factors that it's not going to change it. So if I look here, I've got 2, 3, 2, and 5. If I go back to my sieve and I think about it, I know that my first prime factors were 2, 3, 5, and 7. So looking at these bottom numbers, I know they're all prime. So I would represent this in the following way. I could take my 2's and put them together. 2 times 2 is 2 to the power of 2 times 3 times 5. And if I multiply all those together, it should go back up here and give me 60. I can do this another way, just to show you that we should come to the same answer. If I go over here and multiply 60 together, I could say, well, I know that 2 times 30 is 60. 2 is prime, so I can leave that alone. 30, I can get 3 times 10. 3 is prime, I can leave that alone, and 10 is 2 times 5. Okay, I'm not going to bother to multiply 2 times 1, 3 times 1, etc. So if I look at these values here, I get 2 times 3 times 2 times 5. And again, writing that down, I can use exponential notation. So I've got 2 to the power 2 times 3 times 5. Again, I can represent these composite numbers as a product of their prime factors in this way, using what we call a factor tree. Another way I can find the product of prime factors from any composite number is to use something called repeated division. You'll also see it called the upside down birthday cake in some instances. So, same kind of thing, I'm going to start with 60, but I'm going to start dividing it. And what I'm going to do is divide it by the first prime number, so I'm going to start with 2. So the question I'm going to ask myself is, can I take 60 and divide it by 2 evenly? And the answer, of course, is yes. 60 divided by 2 is 30. So I'm going to see if I can divide it by 2 again. Can I divide 30 by 2 evenly? The answer is yes. It ends in an even number, so that's doable. So 2 divided by 30 is 15. Now I know I can't divide 15 by 2 because it's an odd number, so I'm going to go to my next highest prime, which is 3. So I'm going to divide 15 by 3, and I know that I can divide 15 by 3 evenly. 15 split into 3 groups would give me 5. Now 5 divided by 3 is not going to work. I'm going to end up with a decimal. So I'm going to go to the next highest prime. So my next highest prime is 5. 5 divided by 5 is 1. And I'd like to think about at the end here, when I get to 1, I just say it's 1 and done. I can't go any further. 1 is the last factor. It's neither prime nor composite. I can't divide it any further, only by 1. So I'm pretty much finished. Same sort of thing. I have 2 times 2 times 3 times 5. I can put that into exponential notation, which is 2 to the power 2 times 3 times 5. So here are two methods of representing numbers as product of their prime factors. Feel free to choose whatever method you find most comfortable, and we'll hopefully talk to you soon. See ya.